is it important?
Because we would be dead without it.
Yes, that is very true. We would be dead without it. Also, what about, what's a common etiology of people that we see?
Strokes.
Stroke, exactly. You guys. So it's really important for us to know about the blood flow so that we can know more about stroke, because depending on where the blood flow stops, depends on what kind of stroke they have, depends on what kind of communication will result in different communication difficulties. So it's important for us to know. So that being said, the blood supplies the brain with needed nutrients such as glucose and oxygen, and it removes the CO2, the carbon dioxide, from the neurons. So neurons by themselves can't hold on to or store oxygen, so they need a constant supply of oxygen, which is why we have blood that carries the oxygen to the neurons. And the brain is very disproportionate in the fact that it's only 2% of our body weight, but it consumes 20% of the oxygen that we use, so it's really important and vital. You go 5 to 8 seconds of circulation interruption. That's not holding your breath. That's no oxygen to your brain for 5 to 8 seconds, and you can become unconscious. And if you go 4 to 6 minutes, you can have irreversible brain damage. So it's really important for us to know in our field, because we're going to see people that have the effects of circulation interruption. Okay, so we have the two. We have the anterior here and the posterior route here. So I'm going to go back to the earlier slides. Okay, so getting the blood up to the brain, we have our anterior route that I showed you guys at the front, and that's the internal. Oh, actually, let me. Okay, so you see the common carotid artery. See how it splits? It bifurcates into the external carotid artery and the internal carotid artery. You guys see where that is? Okay. So the external carotid artery, the one closest to your face, it supplies blood for your face, your nasal area, your oral area, and the internal carotid artery goes up into your brain and supplies blood to your brain, and it joins into something called the circle of Willis, W-I-L-L-I-S, and we're going to talk about that in a minute. And it eventually divides into the anterior cerebral artery and the middle cerebral artery. But as we go through the slides, you guys will see that. Okay, so the anterior route that we showed has the internal carotid artery. Remember how it split? So not the very anterior one, but a little more posterior, is the interior carotid artery, and we have a right and left. So we have two carotid arteries that come up on either side of our neck, and then they bifurcate and split. So it comes up from the aorta up the side of the neck. And this branch, the internal carotid artery, it supplies the anterior, medial, and lateral surfaces and structures of the brain. So the posterior route is the vertebral artery. Remember the artery that came up through the cervical vertebrae, the one more posterior? That's the posterior route. So the vertebral artery comes up through the cervical vertebrae, and there's a right and a left of that one also. So it comes up from the aorta through the vertebral column and along the brainstem. And it fuses to form the basilar artery and branches to supply the cerebellum, inferior and posterior surfaces and structures of the brain. So let me go back to the picture so you guys can see. So you see the vertebral artery that's going up through the cervical spine. It looks like it's just one, right? But it's actually two. And as, let me get my little pointer. So see how it looks like one, but then see how you can see there's two right there? So really, there are two vertebral arteries. You can see that there's two right here, and then they fuse together to form the basilar artery right here. Does that make sense? Is everybody following me? It's kind of confusing when we first talk about it. So once more, we have the anterior route right here. Oh, good, you can see my pointer. We have the anterior route, which is the common carotid artery, and there's one on either side of your neck. Willis is a ring of arteries at the base of the brain. I'm going to show you a picture and then we're going to come back to it. So this is a picture of the circle of Willis. So it's just a different view where you can see the vertebral artery right here, the two vertebral arteries that we talked about, how they fuse together to create the basilar artery right here.
Are we looking up from the bottom of the brain?
It's an inferior, yeah, it's like cut in half and you're looking up. This is the cerebellum, and this is the brainstem. Okay, so the basilar artery comes up, and then it kind of splits off like this into the posterior cerebral arteries. I don't know why I keep losing the pointer. So it splits off into the posterior cerebral arteries. You guys see how it kind of makes a circle? All the different arteries come together. That's called the circle of Willis. Okay, so right here we have the posterior cerebral artery. One goes off there, one goes off over here. And then here we have, in the middle, we have the middle cerebral artery. Kind of makes sense. And then up here we have the anterior cerebral artery. So connecting these arteries are tiny little areas right here. You see that little area right there? That is the anterior communicating artery. So communicating arteries are little mini pieces that connect the circle together. So the reason the circle is important is because it allows blood flow to be equal throughout the entire brain. Because it's a circle, so it's continuous. Does that make sense? And also if there was a blood clot or something, or I guess a slower part, it's a circle, so it will continue to bring the blood flow around. So we have the anterior communicating artery, which is that small part there. And then we only have one anterior communicating artery, but we have two posterior communicating arteries. You guys see where that is? Right there and right there. Please let me know if you guys need me to repeat anything. So posterior communicating artery, and a little sliver here, anterior communicating artery. And then we have the anterior cerebral artery, which we call the ACA, that goes all the way up here. The middle cerebral artery, the MCA, that comes across here. And the posterior cerebral artery, PCA, that goes down into the little vacuum hole thing.
I have a question. What is that in the middle? That the arteries are going around in the circle of Willis?
I believe that's just cutting off other veins and arteries of the blood flow, but I don't think.
It's not the thalamus, right? It's just,
No, I think, because it looks like it's kind of tubes like a vein or an artery, so I think it's just cutting it's doing a cross-section of that, but you don't need to know it, so that's my best answer for you.
that's all right, I was just curious.
Yeah, no, that's good, I'm glad you asked. Okay. Okay, so as we talked about, the circle of Willis is a ring of arteries at the base of the brain. You have three cerebral arteries. Remember we talked about the anterior cerebral artery, ACA, middle cerebral artery, MCA, and posterior cerebral artery, PCA. And those different arteries take the blood to different brain structures. And then we have the two